This has never happened before, where a room went quiet without having to ask it to be quiet. Nice start. Good evening and welcome to the Moose Family Speaker Series on water resources. It's presented by Freshwater Society and the university's College of Biological Sciences. I'm Steve Woods, I'm with Freshwater. For Kathy Lake's presentation tonight, we are fortunate to have the Metropolitan Council Environmental Services as a major sponsor. They were instrumental in bringing Kathy here as a representative really from a peer organization that not only treats multiple wastewater streams but also cares about the natural streams as well. We are also sponsored tonight by the Elm Creek Watershed Management Organization. They are managing on the urban fringe up there in northwestern part of Hennepin County, and together really both these organizations know that working the upper watershed makes a big difference downstream. Freshwater is about to start our 50th year. What we do is we propel the best water research and policy that we can find into action here in Minnesota. What I think we do pretty darn well is we help activate people to take their next steps, to contribute their part of the solution, whether they're mayors, city engineers, cabin owners, landowners, farmers, governors, whatever. Here's an example of how we tend to do that. One vital way you, people in the audience and watching online, can take your next step is by investing in our work. This Thursday is the annual Give MN Day, where nonprofits all across Minnesota are making appeals for support for their causes and their organizations. We hope that as you consider the stream of emails you're probably already receiving, that you consider keeping Freshwater in your minds as one of your top 3 charities that you like to support. If you're new to us, let me explain how this evening is supposed to work. Kathy Lake will give the best presentation you've ever heard about making clean water. You're welcome, Kathy. That should take approximately 45 minutes and 17 seconds, according to Kathy. Then Dr. Carrie Jennings of our staff will host a discussion with Kathy and Paul Nelson, Paul will inject a bit of local flavor into this topic. We'll give both those other 2 people full introductions after Kathy's talk. Throughout the night, you'll be able to enter questions via the unfortunately named Pigeonhole Live app on your phones. You should have received a flyer when you checked in at the registration table that has the instructions for how Pigeonhole Live works. Essentially what this does, it allows you to be on your cell phone even while Kathy is talking, without the normal social stigma that comes with people who do that. We've been pulling tonight's presentation together for about 6 months. If you recall, last year we had Bill Stowe from the Des Moines Water Utility. He was discussing drinking water systems at the time and how the upstream decisions have downstream costs that the Des Moines Water Utility ratepayers were handling. George Hawkins followed him. George was with the Washington, D.C. area, D.C. Water. He talked about how he handles being on the downstream end of a very, very large wastewater system. After that, we had Janet Atarian. Janet talked about how urban streetscapes can be a part of solving polluted runoff problems. And tonight, we are pleased to have Kathy Lake with us to kind of stitch all those themes together. Again, no pressure, Kathy. When you think about it, the Madison wastewater treatment system sits at the downstream end of a lot of decisions. Some of those are long-term, some of those are short-term decisions that landowners are making a cajillion times a day. Either way, she and her crew manufacture an awful lot of clean water, which, if you think about it, that's what wastewater plants do. They make clean water, they're just misnamed. And they do that making of the clean water within the confines of a fairly small, fenced-off footprint. And that's where the final point of my introduction comes in here. During one of our planning conference calls, Kathy used the phrase, working outside our fence, as shorthand for what they were attempting to do. All those decisions upstream, all that potential upstream, was something they hoped to tap by working outside their fence. So tonight we really, truly do have an outside-the-box thinker on hand. So, to get down to the actual introduction of Kathy. Kathy is the Pollution Prevention Manager for the Madison Metropolitan Sewerage District. She's a native Minnesotan who earned her civil engineering degree here from the University of Minnesota, and then she got an MBA from some Big Ten school in Wisconsin. For over 20 years, she has been pursuing innovative solutions to water challenges as both a consultant and a municipal employee. She leads the district's chloride reduction program, which is where we first heard of her at our road salt symposium 2 years ago, and now is president of the Yahara WINS, the watershed-wide, multi-jurisdictional phosphorus reduction project that the district leads. Her environmental influence in and beyond Madison is the reason why she was one of 6 forward-thinking women honored in the 2016 Women of Industry Awards program by the Chamber of Commerce in the Madison area. Ms. Lake's talk tonight is titled Protecting Water Through Innovative Collaboration. Please welcome Kathy Lake.
I'll do my very best. Hello, can everyone hear me? Okay, well there, we got the first step here. All right, well thank you all. Thank you to Freshwater for this opportunity to come and talk to all of you about a lot of the things that are going on in our water. Water is essential to life. It's something we depend on. It's something that we don't think about though. When you think of water, where is its value? What's important to you? Is it a cool drink on a hot day? Splashing in a lake? Taking a long bath on a hot day? Or canoeing down the river? We have many relationships with water. Some as basic as survival, others as unique as our pastimes. It's also something that we don't think about. We are so lucky to be surrounded by freshwater resources and have reliable drinking water supplies and treatment for our waste. But as important as water is to each of us, it's also something we can and do many times take for granted. My goals for today are for each of us to think about water a little differently, and to think about how our mindset, our action, or our inactions are very important today and for generations to come. I'm lucky. I've spent my entire life around fresh water. I grew up in Duluth, and I just assumed that all water was clean and clear and actually very, very cold. And I've also been really lucky that throughout my career, I've got to work with water. I've worked with drinking water, wastewater, stormwater, rivers, lakes, streams. And for years, we thought about each of those waters very differently. They were either clean or they were dirty. It was part of this region or that river. But in reality, the water we have today is the same water that the dinosaurs had, and the same water that our great-great-great-grandchildren are going to inherit. Those silos that we separate that water into exist only in our minds, in our policies, and our regulations. But because they've been institutionalized for so long, they're really hard to get by. The complex challenges of today require us to think about this differently, to reevaluate our mindset, to look at barriers and look at solutions very differently. As Steve mentioned, I work at the Madison Metropolitan Sewerage District. This is a picture of our wastewater treatment plant. We have one large wastewater plant that serves about 25 municipalities in the greater Madison area. We serve about 350,000 people. We see ourselves very much as a resource recovery facility. Every day, we recover over 40 million gallons of water, and we clean it, we return it safely to the environment. We also generate and apply millions of gallons of fertilizer to local farm fields to help with food production. We gather and generate over 35% of the energy our plant needs through renewable resources. And we're pushing resource recovery even further. We recently added a process that takes additional phosphorus out of our fertilizer, crystallizes it into little pellets that we have that we can ship out of the watershed to areas where phosphorus is needed. We've also looked at other resources. Last year, we took some of our treated water and we ran it through additional treatment. We treated it to drinking water standards. And then we had a taste testing at the plant. And about a third of our staff tried that water. But then we brewed it into beer, and a lot more people tried it. We called our beer the Nine Springs EPA. So we have the Nine Springs wastewater treatment plant, and it's our effluent pale ale. Our treatment plant is a regulated point source under the Clean Water Act. And in my lifetime, the Clean Water Act has done amazing things. We no longer have untreated waste discharging directly into our rivers, lakes, and streams. Our rivers aren't catching fire. But the unique challenges of today are pushing us into new territory. For example, in our watershed, phosphorus is our controlling nutrient. And phosphorus is what we need to make plants grow. So we need it on our landscapes for our plants to grow. But when that phosphorus runs into our water bodies, it's helping the aquatic plants and algae to grow and making our waters not as attractive and outside of the realm of what we consider acceptable. Our wastewater plant does a remarkable job of removing phosphorus. For years, we've continued to improve the processes at our plant, and currently we remove over 95% of the phosphorus that we receive. But because our streams aren't meeting our intended use, our state has enacted new phosphorus requirements, new water quality standards. And those water quality standards would require another 70% reduction in phosphorus from our plant. Historically, when we had a new challenge or a new regulation, we knew how to fix it. We're engineers. We plan, we figure it out, we build it, and then we have a reliable system that will meet that criteria. The problem with phosphorus is that we're not the only source of phosphorus. Phosphorus is coming from our yards, it's coming from our construction sites, it's coming from our farm fields, it's coming from the leaves in the gutter of the street. All these sources of phosphorus are entering our water bodies. When we look at our watershed, the blue pieces are those pieces of the pie that are the sources that are point sources, so other treatment plants in the district. So if we were to construct treatment at our plant and we were to remove that 70% of additional phosphorus, we would help the problem. We would solve a portion of the problem, but our water bodies still wouldn't meet water quality criterion. And that's because of all those other sources. When our state was looking at the concept of this new water quality standard, they convened an advisory group. And that advisory group was very forward-looking. And rather than fighting the minute details of what that standard actually was, they looked at the big picture and looked at potential alternative compliance options, other ways to get to the ultimate goal of clean water that didn't lay solely on the shoulders of the wastewater treatment plant. So we have many options to comply with this water quality standard. We could construct a treatment plant expansion. We could do water quality trading, so we could offset what we discharge. Or we could do something called adaptive management. And adaptive management is new. It's something that came with the new water quality regulations in the state. There's another variety of potential compliance options. But as a point source discharger, we needed to look through all these options. We looked at the watershed options of trading or adaptive management. So water quality trading or pollutant trading is something we hear a lot about. And when we look at pollutant trading, we're looking at what is that source discharging and how do we make up that amount of load somewhere else in that watershed. When we look at adaptive management, we're looking at the water body itself and how do we get that water body to achieve the goals of the Clean Water Act? How do we get that water body to achieve that water quality standard? So one of them is focused on offsetting what we're putting into the water, and the other is taking a whole step back and looking at all the sources and how we get to actual water quality compliance. So as we looked at this whole suite of possible compliance options, adaptive management started looking like a very viable option, but it's brand new. Wisconsin is the first state in the country to have an option of adaptive management in our code, and we were also the first organization that was trying to make it happen. So rather than jumping in completely and saying, okay, we are going to make adaptive management happen, we kind of dipped our toe in. We started with a smaller pilot project, so it's not that small, about 11,000 acres and 4 years long. We invested $3 million, and we looked at if we could test adaptive management and see how we could make it work. We looked at how are we going to make it work? How are we going to bring partners together? How are we going to get practices on the ground? Could we get the suite of practices on the ground that were actually achieving water quality? And if so, how much did those practices cost? So we used that 4-year pilot project to answer a whole lot of questions about adaptive management. And at the end of the day, we decided to move forward with adaptive management. We were moving forward because we learned a lot. We learned a lot about how to make something like this happen. First, it takes a lot of partners. Our adaptive management project is very large. It's incorporating many, many different landowners, many different municipalities, many different permit holders who speak very different languages. We have different goals at the end of the day, but our ultimate goals are very similar. So as we got to know people and we started talking to people, we learned how to make things happen, how to get the practices that we needed on the ground, and what barriers there were to action. Whoops, I don't think that's right. Okay. We also learned that it was very, very challenging to go, as Steve said, outside our fence. So for the district, for the wastewater treatment plant, it's a scary thing to have to depend on others and take those risks of other people doing things that will ultimately lead to our compliance with our discharge permit. But all the municipalities that are part of our project, which is stormwater entities and other groups, all had to do the same thing. We pooled resources and we pooled money so that we could invest in a low-cost mix of practices, and that meant we were taking money from parts of the watershed and moving them to completely other parts of the watershed. So people couldn't look outside their window and say, my money purchased that. The city councils couldn't say, our money is going to that staff within our government. No, it might be going to a staff in another government that's actually helping this project move forward. So we moved from a pilot project in this small test project to this larger scale project. We ended up having 5 cities, 9 villages, 10 towns, and I know in Minnesota your government structure is a little different, but in Wisconsin, cities, towns, and villages, they don't work together. So this is a very unique thing to actually have, 1924 municipalities actually working together with the same common goal on the same project. We also had 3 wastewater plants, 2 other point source dischargers. One of those was the fish hatchery, which is owned by the Department of Natural Resources. So there are permitter, but they're also permitted under the state law. We had 3 counties. Our watershed spans 3 counties. We're very lucky to have a group of very progressive farmers in our watershed who are working to get conservation actions throughout their networks of neighbors and friends as well. And we also had a lot of different environmental groups and lake associations that were part of the project, are part of the project. We call the overall project Yahara WINS. Yahara is the watershed, and the Watershed Improvement Network. We found there were a lot of practices that we could put on the landscape to achieve phosphorus reductions. And a lot of those practices cost a lot less than what it would cost to invest in treatment at the wastewater plant or at our stormwater entities, our stormwater systems. We worked with farmers to put in cover crops. And we worked with farmers to figure out new ways to put in cover crops. We had about 2,000 acres of cover crops flown into standing corn this year because they didn't have enough time to plant them after the harvest and actually get them established in time, because in Wisconsin, like Minnesota, winter comes kind of soon after harvest. We also worked on putting waterways and buffers. We have a lot of animal agriculture in our watershed, and we worked on different manure handling. This is a compost project that our farmer-led coalition started, worked hard to invigorate, and then is currently trying to replicate throughout the watershed. We worked on buffering stream banks that were eroding, and we invested in a lot of research. One of the research projects that Yahara WINS invested in was leaf management. The USGS office in Madison looked at what urban leaves were contributing to phosphorus runoff. They studied set neighborhoods in an urban environment, and then they did things. They did no leaf collection at all for a couple years, and they monitored what the phosphorus runoff was. Then they started working in a couple neighborhoods. One neighborhood, they had all the landowners bag their leaves and keep them on the curb. Then they had another neighborhood where they actually took all those leaves out of the street. So any leaves that ended up in the gutter of the street, they took those out. They found a huge reduction in phosphorus in the neighborhood where they took the leaves out of the street. And that dissolved phosphorus, it was almost all dissolved phosphorus. So the water was sitting on the leaves in the gutter of the street, leaching phosphorus out, and then that phosphorus was available for plant growth. And that ended up being the largest source of phosphorus in the urban environment in our region. In our region, we do have a ban on phosphorus in fertilizers for residential land. So in our area, without that residential fertilizer component, the leaves in the gutter in the fall are the largest source of phosphorus. We also worked really hard to figure out how to judge our success. We have the ability to look at models as well as in-stream monitoring. At the end of the day, we need to be able to prove success by the in-stream monitoring. And we have a very robust water quality monitoring network. We have some major continuous installations of water quality monitoring stations, but the majority of our water quality monitoring is done by citizen scientists. And they're in the stream every month taking their samples. Our lab is analyzing those samples, and we're funding one of our watershed groups to coordinate those volunteer monitors. So when we looked at the success of the pilot project and moved to a full-scale project, we asked all of our partners to evaluate their compliance options. Was this really the direction they wanted to go, and did this make the most sense for their future compliance with their permit? So the wastewater treatment plants are permitted, but also all the municipalities that have stormwater systems also have permits. So they looked at how much it would cost to comply on their own, whether they had resources, whether they had available land, whether they could actually make it happen. And then all the treatment plants looked at all our options as well. And the district decided, based on our thorough evaluation, that we wanted to go, adaptive management was the most attractive option. That's the direction we wanted to go. But because we had that entire 536 square mile watershed to consider, we couldn't do it by ourselves. We needed all these partners pulling together. So we went to all the different municipalities. We talked to multiple boards at each municipality, and we explained the different compliance options. And what ended up getting almost all of them to sign on to adaptive management was the business case. At the end of the day, Adaptive management was significantly cheaper, and it would take significantly less of their staff resources to make it happen. We also worked out the details with our regulators because every adaptive management project is going to be very different. Every watershed is different. Every organization pursuing adaptive management is different. So we worked with our regulators, both DNR and EPA, to develop a memorandum of understanding that laid out what adaptive management would look like, what compliance would look like, so that we would have the foundation and the framework to move forward with a full-scale project. So we're moving full speed ahead on a multi-jurisdictional 20-year project aimed at reducing over 100,000 pounds of phosphorus entering our water bodies that will achieve water quality compliance in each of the reaches of that watershed. But it's not our only challenge. There's other wicked problems out there. And for us, salt is a big one. Every day at our treatment plant, we get more salt than this pile. And that's my coworker, Ralph. He's 6'7". And we get 20 tons more than that each and every day of the year. Salt, I think there's 14,000 approved uses for salt. It works. And if there wasn't any environmental impact, we'd continue using it. We put it down on the pavement or we put it in our water softener. It dissolves. It seems to go away. We don't think about it again. And because I'm sick of talking, how much fresh water do you think would be polluted by 1 teaspoon of salt? When I say polluted, I'm talking about exceeding EPA's chronic toxicity threshold, which is 230 milligrams per liter, or the amount that a freshwater organism could stand living in for an extended period of time. Yeah, I can't see any of you, but 5 gallons of water. So 1 teaspoon of salt permanently pollutes 5 gallons of water. So if we could use 1 less teaspoon, we could protect 5 gallons of water forever. But if we use 1 extra teaspoon, we've contaminated 5 gallons of water forever. Chloride is one of those constituents that persists. It doesn't go away. It stays in our water. We see the concentration of chloride increasing in our wastewater. Over the last 25 years, the trend is up. We get over 225,000 pounds of salt at our plant each day. In a year, that's 80 million pounds. That's a lot of teaspoons. We also know there's a lot that's put on the roads. All the salt that comes to our wastewater treatment plant comes to us, passes through, and it goes into a freshwater stream. Our freshwater stream is 10 miles south of the municipalities that are our ratepayers, downstream. But we're seeing that salt ending up in all of our waters. We're seeing it ending up in the wastewater, in the drinking water, in the rivers, lakes, and streams. We're seeing incredibly high trends of salt increasing. So when I talk about chloride, we've got sodium chloride. So the chloride portion is the piece that is toxic in the freshwater environment. The trend at the top shows our major lakes. We have 5 major lakes in the city of Madison, or the Dane County area. We call it our chain of lakes, and it's our prized jewels of the entire community. Since we've been putting salt on the roads, the trends are really scary. The upper lake is kind of our smallest dilution. The bottom one is our largest lake, the most dilution. But either way, the chloride is increasing very significantly. If it's not ending up in our surface water, it's ending up in our groundwater. And we drink groundwater in my area. So we see on the left, the relative concentration of chloride in our drinking water wells in 1995. And then we see it 15 years later in 2010. And those trends are continuing. They're continuing and they're very scary. So again, if we had this problem years ago, the wastewater treatment plant, we would figure out a way to build a solution. So we looked at that again this time. We hired a consultant, and they looked at what it would cost to treat for chloride. $400 million to $2.3 billion. You know, we don't have deep pockets ourselves. That's going to be absorbed by our ratepayers, which would increase their rates 55% to 500%. That would look at either treating the source, some of the source water to remove hardness so we didn't need to soften it, or removing some of the chloride at the wastewater plant and blending it into the rest so we could just keep ourselves below the water quality standard. These don't make any sense. So we applied for and received a variance from the Department of Natural Resources. As part of that variance, we asked for additional time to look at reducing the sources of chloride. If we can reduce the sources of chloride that come to our plant, we can get our discharge to meet water quality criteria. If we can reduce the sources of chloride, we can also help our lakes, rivers, streams, and drinking water in our basin, because those won't be helped at all if we only work on our plant, because it would help the water 10 miles away from where the core of our ratepayers live. When we talk about reducing sources of chloride, we're talking about trying to put in place resilient solutions, looking at improving the quality of water softeners, improving the efficiency of equipment, looking at how much water really needs to be softened. About 50% of the load of chloride that comes to our plant is from water softeners. Road salt is about 10%. Drinking water, we're seeing that come to the plant as well, another 5 to 8%. But we're looking very hard at road salt as well. And the reason we're looking at road salt improvements is because we see that in very small pieces of the year, very tight. When we have a winter melt, we see that road salt finding cracks or holes in the sewer system, in the manholes of the sewer system, and coming to our plant. And those small peaks would actually send us over our discharge limit. So we're working with a variety of partners. We're working on meetings, we're working on trainings, we're working on looking at what new equipment is out there. We're funding a lot of different programs. We're funding grant programs. For large users, we're paying $1 a pound for people that can come up with ideas to reduce chloride at different facilities. We have innovation grants right now. We have kind of a list of things that we want to have happen within our service area to reduce chloride. And if somebody wants to try one of those, we'll help fund it. We also have road salt equipment grants. We've been doing a lot of training on, and Connie Fortin is here that has been helping us with training on getting the application rates, the right application rates, empowering those who are applying salt. But sometimes it's not enough to empower. Sometimes you need new equipment. So we have grants to remove those barriers. So looking at each of the challenges and what are the barriers that are really there, what's really needed to make that change, and we're trying to infuse our time, our resources, where we can really make change happen. When we look at road salt, we're not looking at reducing the safety. What we're looking at is changing misapplication or misuse of salt. There's a lot of extra teaspoons here. There's also a lot of infrastructure damage from over-application. But there's also a lot of science behind the right application rates. We're working on behavior change with a variety of partners. We pulled together a lot of different partners within our region. We pulled together the county, the public health department, the county, the city, the regional planning commission, the University of Wisconsin, the DOT, and we talked about what is it going to take to really change the amount of salt being used in our watershed. And it turned out what we really needed to change, we needed people to understand salt. We needed people to look at their social norm. So when we started salting roadways, we started plowing, I think a lot of us forgot how to drive. We expected that we could get to Walmart at 8 a.m. on a snow day, and we could get there at the same speed we could in the summer. But that's a social norm, and that's an expectation. But that doesn't have to perpetuate going forward. It's something that we can work to slowly change. So we looked at targeted audiences. What did we need to get in the hands of motorists so they could try to make good decisions? What was it that homeowners needed to learn the right application rates? We worked on developing outreach information, specific targeted information. We developed cups that were the right amount of salt for 10 sidewalk squares, and we handed those out to people so that they could try it themselves. We put these shovel scatter switch posters where you purchase salt in your farm and fleet or wherever you're purchasing salt, to let people know that mechanically removing the snow first should be their first step. There was a right way to salt. And then also, if it was too cold, salt wasn't going to work, but there were other opportunities. So we've worked a lot on partnerships. We've worked a lot on bringing people together. We've worked a lot with a lot of different people on understanding their barriers to action. And once we understand each other and we talk to each other, we really can start making things happen. But our water needs each of us. It needs each of us to do something different. It needs our actions, and it needs us to think differently about our inaction. These new challenges require new tools. We need to look at partnerships. We need to look at working with people who speak different languages, who think about things differently, who come from different political parties. We need to think about how we can work together for the good of something we all depend on, and that's fresh water. And one thing I want to leave us with is that success is happening. The 2 case studies I've been talking about are happening, they're working, they're making progress, but there are a huge number of projects throughout the country, throughout the state of Minnesota, people are doing amazing things, people are doing wonderful things, and each of us has the opportunity to contribute. So in summary, as we think about water a little differently, think about what it is that we're doing today and what we could do differently and who we could work with so that the water we leave our children is the best it absolutely can be. Thank you.
I think we can agree that was okay. Wow, thank you, Kathy. I am eager to keep the momentum going here and get to the questions and audiences, so please remember to keep putting in some of those questions into the Pigeonhole Live system and voting on those questions you want to see elevate up to the top of the list. Cody, if we could maybe bring up the audience lights a little bit, they might have an easier time typing into their little communication devices, just a wee bit. Thanks. And so, in the meantime, we're going to be setting up the stage here for the conversation that Dr. Jennings is going to lead. So, Carrie, if you'd like to come on up. Carrie Jennings is our Research and Policy Director at Freshwater. She applies her extensive background to Freshwater's policy work in surface water pollution and groundwater sustainability issues. She has mapped the superficial geology of about half the state during a 24-year field geologist career, and she maintains pretty strong connections here at the U of M, where she did her MS and her PhD. She's an adjunct in the Earth Sciences Department, chairs the External Advisory Board, and is a member of the faculty in the Water Resources Center. Where do you find time for all this? She has taught field-oriented glacial geology course for the last 24 years and mentors graduate students across the university campuses. She will be talking today not only with Kathy, but with Paul Nelson. Paul admits to having worked with me in the past and at several other consulting firms over the years. He's wicked smart at the technical things that you'd expect from somebody who's a trained water quality scientist. But on top of that, he also is pretty skilled at using the social sciences to figure out how we get a cajillion people to all do slightly better on their portion of the earth that they own. He is currently Scott County's Director of Environmental Services, and I'd like to have you come up the stage too, Paul. And I will now turn over into the capable hands of Dr. Carrie Jennings. Yeah, Kathy ought to be up here too.
All lovely ones. Yeah, but we're just going to hold them. Yep.
There's a handheld if you'd prefer.
Okay. Is this on? Check, check. That one's on. Which one's on?
That one's on.
That's okay.
It wasn't working.
Well, I think a lot of us feel a kinship to people from Wisconsin, and you especially, since you are a Minnesotan. My primary question before we get to Pigeonhole is what's different about this Yahara watershed? How were these people so individually motivated to make these changes happen? It seems like that farmer-led coalition and the volunteers measuring water quality. Is there something special about that watershed or that place?
There's a lot of really interesting things about that watershed. The Lake Mendota is the most heavily studied lake in the nation. It's where limnology, the study of limnology or water science started. And that's the big lake on the upstream part of our watershed. The gem of lakes, so that chain of lakes, is the center of the community. It's what people associate with Wisconsin, with Madison. And because people are so close to those lakes and the rivers and streams, just like your resources in your neighborhoods, you really truly care about them, you want to do something different. There's a lot of people and organizations that are very interested in making those connections, making something good happen. And the more energy around that, the more people want to engage and want to be part of it. I didn't talk a lot about this farmer-led group that is in our watershed, but they're amazing. It's a group of conservation-minded farmers that have come together and are trying and testing new practices, new things, how they can make what works on one farm work on another farm. And Yahara WINS is helping fund some of those practices, but they're doing the work. They're bringing people in from all other watersheds throughout the nation and actually throughout the world to try and test new practices, things that they've seen other places that have the potential to really work. They want to lead the way in making water quality happen.
That's amazing. And Paul, in Scott County, you're working in the Sand Creek watershed, Sand Creek watershed, right, in a similar coalition building effort. Can you describe that? I'm going to give Paul a little chance to say what he's doing.
Yeah, in Sand Creek, we've received one of the state's targeted watershed grants, and there we're partnering between 3 counties. There are a number of cities in that, and then also 3 different soil and water conservation districts. We have a lake improvement district that's part of that, and several sportsmen's club, and we have a farmer-led council as well that we're working with.
Well, so to the questions now, Pigeonhole. And I feel like I'm a little live here, so I'm going to put that down a bit. So for both of you, what were some of your most significant challenges working with so many different partners who have many different goals?
First of all, you have to be ready to give up some control. And listening to Kathy talk, I've done some work for the Madison Sewer District when I was in consulting years ago, and it aged me a little bit because everybody I worked with there is now retired. But it occurs to me when you talk about going outside your fence, you're going out into an area that's somewhat unknown. And I also wrote down lots of things here, but you also talk about relying on other people. So you're giving up some control. There's a whole lot of relationship building that then goes into that and developing trust. So, and it's the same with us in Scott County. You know, we've developed different roles. Scott County, I do the planning, I find the money, and then the SWCDs get to spend it. So.
Do you have anything to add, Kathy?
I think you hit the nail on the head in that you're taking additional risk by not being in control. And that's a very different feeling for our organization and other organizations. Historically, we've been able to fix any of our challenges within our fence, really the fence around the treatment plant. We're able to build, we're able to figure it out, we're able to have complete and total control over that outcome. But if we start looking at the entire watershed, we're looking at the climate, we're looking at climate change, we're looking at others' actions really mattering to our success and our ability to meet our requirements. And that and the fact that we're moving money all around to different people and different organizations is a very, very challenging piece.
Mm-hmm. Is this going to advance to the next question? There it is. Is chloride or phosphorus more dangerous to waterways, and which is the best to focus our efforts on?
There's a whole multitude of challenges. And phosphorus and chloride aren't the only two. They're two that are really big in my life, but there are a lot of challenges in our waterways. We also have invasive species. We also have nitrogen. So if you're looking at your area, you need to look at what is really controlling the future health of your waterway. We see horrible trends in chloride, and chloride's toxic to freshwater environment. We see dead zones in the Gulf from too much nutrients from this area, but close to home, nutrients aren't toxic to our organisms right here in the state, but they are in total. So it's really looking at all the trade-offs, and I think looking at the concept that there is no way, that all of our actions matter. This concept that once we do something, it goes away, doesn't really exist. It does have that impact, and it has that impact either close to home or far away.
Yeah,
And I'm going to just ask you to describe Sand Creek Watershed a little more for people that aren't familiar with Scott County and that region.
Sand Creek discharges to the Minnesota River, and it starts way up in Lonsdale in Rice County and flows then north, northwest, up through New Prague, then Jordan to Minnesota River, about 270 square miles. And part of this partnership thing, about only 60% of it's under our control.
It's still quite a bit of farmland. So chloride or phosphorus?
Majority land is phosphorus. I'm going to say it depends on who you ask. What are your concerns? What are your water quality things? I think the larger question to me there is that chloride, phosphorus, aquatic invasive species, is that the scale of the issues is enormous. And we don't have enough money to solve it by building stuff. We have to recognize that given the scale and the multitude of these issues, and that, listening to Kathy, what you do for chloride is different than what you do for phosphorus. It's become, when they went outside their fence again, they went from dealing with what is called a complicated problem to a complex problem, and to a social dilemma where you're relying on other people. And so I don't know that I can say which one's, that's in the eye of the beholder.
Maybe it will change with time because you're both probably experiencing some development pressure in your watersheds. So shifting.
Mm-hmm.
Okay. Next question, I think. What are key motivators for ag producers to participate in Yahara WINS?
We have many different sources of phosphorus, but when we look at that low-cost mix of practices, we're looking at a majority of those practices that are occurring in agricultural lands. There's a lot of different motivators. The big overarching motivator for Yahara Pride to get involved and to really look at solutions was a fear of regulation. They don't want to be regulated. And if we can work our way out of this problem without regulation, they want to be leading that. They want to move that forward.
And that would be regulation at the state level or the federal level? Or
Any?
any? Okay.
Yeah.
And what about your participating farmers?
I would echo the fear of regulation as a motivator. The other thing, social norms, which we bring up frequently, does work with the farm community. They talk to each other. They know what's going on. Financial incentive is a big one. We just recently completed a survey of folks who have participated with us in over 400 or so practices. And two things that come out as more on the barrier side is the availability of equipment to do some of the things. Not all of them have seed drills that are able to do some of the practices, or tractors big enough to pull some of the equipment. So equipment availability. And the other one that is coming forward quite a bit with May Davenport's research is what they call self-efficacy, which is actually the belief that you have the ability to do the practice. Do you know how to take care of it once it's built? Do I have the equipment to do it? Do I know how to hire a contractor? Do I have enough money? Can I take that land out of production and still meet my bills? So do I have the actual self-efficacy or ability to do it?
You mentioned somebody that I'm going to jump away from the questions for a moment, May Davenport. Did you want to get a word in there?
Oh, I just wanted to mention one more thing. One thing that you had mentioned yesterday that was really motivating practices was acknowledgement.
Oh, yeah, I send out lots of thank you cards.
And it works.
Hand signed. You mentioned May Davenport, who does social science work here at the University of Minnesota. So was that a person that helped you translate what you were trying to say and do?
Well, I won't plug her joint book, but yeah, May and I do a lot of work, and she's been the one that has designed and completed the surveys that we've done with our folks. And if folks haven't read it, there's a book called Getting to Maybe, How the World Is Changed. And it's stories of people who have taken upon themselves to lead change in various types of things. And they end the book with a statement that basically says those who understand the local dynamics and can leverage them are the most successful at creating change. So getting to know the people, and that's what May has helped us with on a larger scale. We can get to know them one-to-one in our work, but on this larger community scale, May has been a lot of help.
Kathy, did you have a social scientist translator or in your work?
Yes, so we actually have a social scientist on staff that is helping us with, a lot of these projects we're working on, and at the end of the day, you can't say 1 hour here equals 1 pound here, or $1 here is translated to this improvement in water quality. And I kept heading into roadblocks on, we're working, we're building, we're doing the right thing, but how do you quantify it? And we hired a social scientist for that niche to try to help us figure out where our programs, how to quantify our programs, how to look at our solutions, how to look at groups and motivating groups to do things differently. How do we look at these social norms, and how do we work with behavior change? And then also, because we are a government, we are accountable, how do we also quantify some of our work and be able to report some of the successes?
That's great. In order to go outside the fence, how did jurisdictions change regulations or policies to allow spending outside of their realm?
So in our Yahara WINS project, all the municipalities, in the pilot project, we had a relatively small contribution from all the partners. That contribution was proportionate to the amount of phosphorus they needed to reduce in the watershed. When we looked at the full-scale project, those numbers got much bigger. And in the pilot project, we just had a loose memorandum of understanding for those parties to work together. But we actually, on the full-scale project, worked on an intergovernmental agreement where we looked at just that. How exactly are things going to work? How are we going to govern? Who's going to govern? Who's going to have decision-making power? How are we going to set budgets? How are we going to quantify reductions? And at the end of the day, how do we credit back these pounds?
Do you have anything similar to relate?
Well, our Sand Creek project, we have Scott County, LeSueur County, and Rice County. And in Scott County, we are also under the Metropolitan Surface Water Management Act as the Scott Watershed Management Organization. that levy is only raised from people in Scott County. So, but we're working with the other two counties, so we basically have a policy that we will go and leverage our money, our levy, our property tax dollars to get grants, and then we'll use the grant monies to enable the other two counties.
Okay. What do you see as the role of state government in these types of coalitions? And this is especially interesting to us since our state governments are slightly different right now.
Dave, I was telling you, get out of the way. A little bit. I generally believe that the soil and water folks, if you went to them and asked them what are the major things that we need to take care of, know what they are. And they can direct us to them. Then it's a matter of getting it implemented. And our local folks know how to do that, but what we really struggle with is keeping them. They tend to move to other places because salaries or career things are long. So our challenge is, help us keep the people who are really good at getting stuff on the land out there in the SWCDs and places where they're doing that, where it gets built.
And that would be more stable funding for those groups?
Some of it's more stable funding, yes, that with clean water funds or grants being competitive, you don't know long-term how long you're going to have money or be able to retain staff. Some of it's just the attraction of working other places as well. So we do tend to train people to move on to other places. And that's really tough because the relationship part of it is also important. You develop relationships with landowners and you lose the people, you also lose that relationship and some of that trust.
And it sounds like, Kathy, you might have a different story because it sounded like the adaptive management idea was taken at the state level.
So from our state, we have historically had that ability to look at kind of the big picture and what is it really going to take. And that's what I would really like from the regulators and the governments, is taking that step back to look at the big picture. It's not just the point sources, it's not just the way we've done things historically, but what can we really do going forward? What's our ultimate goal, and what are some possible ways to get there? And let the great people on the ground figure out how to get there, whether it's the conservation departments, whether it's the people in the watershed groups working together collaboratively figure out how to get there. But the more we tie our hands, the more we're going to end up back in our historic way of doing things.
Was that driven by a particular thought leader or a coalition at the state level?
So Wisconsin has had great regulatory bodies over the years, and there are people in organizations, and those people are what matter. The people that can really see the big picture, can really see possibilities, can listen to others. And one thing that our state has done very well is when they're looking at new regulation, they're looking at new guidance, they've convened these advisory groups of people within the industry and other stakeholders to really try to get the regulation such that it can work. Because a regulation that doesn't work is painful for everybody.
Mm-hmm. Okay. Are there other ways to eliminate harmful materials in the water by means other than a water treatment plant?
There's a lot of ways.
Yeah.
So as you look at water, you can look at keeping things out of the water or treating what's in the water. There's some innovative things that are going on in the Madison area, which I think are also going on in Minnesota and other places, but we're looking at in-stream phosphorus reduction in stormwater. So injecting alum into the stormwater to precipitate out the phosphorus in a place where you could harvest it. It's kind of an interesting way of dealing with stormwater that's different than our historical methods of swales and ponds. When we look at how to treat water, our treatment plan is pretty much doing what nature does. We're just speeding it up because we have such a concentrated population. So we're doing very similar processes to what nature does, and cleaning the water that way.
Do you have any comments on that, Paul?
No, I don't have anything to add.
Okay,
Is that
okay.
I hope we can do other things. We're spending a lot of money on other practices.
Certainly, starting at the field edge and moving down from there. Okay. How important is educating the public and decision makers, and are we adequately funding such education? And who
I'll
should
start,
do
I'll
the
start again.
educating?
And I was telling Dave beforehand, they ask me to come to things because I'll say inflammatory stuff, and that always is very entertaining. But I don't, this question kind of rubs me the wrong way a little bit in that I don't believe making people smarter changes their behavior. And so you need to be very careful how you parse this. I think there are things that we can do to remove barriers or to motivate people to change behavior. And ultimately, my goal isn't necessarily to make people smarter, it's to change their behavior. And so, and then again, I'll mention May Davenport. We use their moral obligation model where we've identified a number of activators. What are the things that create people to take action, to change their behavior? And we work on those things, which are sort of awareness of consequences, which is an education thing, but also social norms, those types of things, rather than say we're trying to educate people. We're trying to trigger their activators, which move them to an emotional and moral response to do something.
Would the same be said of state government? I mean, the people in the government also need to be approached in that way? They're people too.
Yeah, well, yeah, it's changing behavior is very tough. And what we learned from that and know is that doing conservation is normally not a rational decision. Some cases people can make a little bit more money or they save their land, but most of the time it's not a rational decision. It's going to cost them a little bit more in some fashion. So the way that you get at it is emotion, and it's the same with all kinds of decisions. If you read the book Decisive by Heath and Heath, again, they very much emphasize hitting people's emotions. So I would say, yes, that happens at the state level or even at the legislative level or wherever. It's same type of things that motivate people.
But if I see one more picture of a kid drinking out of a water fountain on a water quality talk, just it can be overdone. Did you have a different approach or similar?
It's very important to figure out who needs a message and what they need to hear. What is it that you really, we worked really hard on Yahara WINS to look at communication. Who did we need to talk to? What did we need them to do? How could we engage people in the way that we needed? We didn't need a full public campaign throughout our region, but we did need to reach the farm community. We did need, and how we reach the farm community is through those messengers, those people that have the connections with others and getting that information out. We needed to reach the municipalities, and how we got that message to the municipalities was very, very different than how we worked with the farmers. It's also very different if you look at those on a behavior change campaign on chloride. They don't all need the same information, and very targeted communication is pretty important.
There must have been missteps along the way where you just didn't quite communicate well with another group. Did anyone just turn away from the process at any point?
There's been, I think the most interesting thing with all these projects is you think that you're going from point A to point B. And what you really do is you go from point A up and around and over here, and then you come up and then you end up somewhere close to B, not exactly where you thought you'd be, but kind of in that area. So yeah, we don't know, we don't have a perfect crystal ball of where we're going. And we've tried some things that haven't exactly worked. We've tried some approaches that haven't exactly worked. But we've had good enough relationships that we've been able to tweak that and move forward still. Sometimes it's taken us going backwards a little bit and over and then back up, but I think developing those relationships is key to making these projects go. Until you really sit down and know a group or a person as individuals and what really drives them and where the real barriers are, it's very, very important to understand that, because otherwise you can be putting out a message that's completely offensive and not even know it.
Mm-hmm. Do you have any experiences?
Well, and then to say, and then you think you've arrived at B, but then there's one community that you need to go and mend fences with because someone else got the transportation money, something totally unrelated to what you were doing, but someone's mad.
Right, right.
So that you have to have those relationships that can last.
Next question. If chloride in groundwater is a big concern, should we be infiltrating stormwater from large, heavily salted roads?
It's a very interesting question. So there's infiltration basins that were built in Madison to offset a draw of water from one of our local lakes. And it was a power plant, had a draw of water from the lake, from surface water. They built infiltration basins to get water back into the aquifer and kind of recharge that water balance. And they built those right next to our major Beltline highway. And they were required to monitor them. And after a couple of years, the salt was so high, they had to discontinue their use. So it is, when we look at wastewater reuse and the ability to stormwater reuse, salt is becoming one of the major controlling items in our ability to reuse that water. This event was sponsored by the Freshwater Society, and the more salt we're putting down, the more salt we're using, the less fresh water we have.
Is reuse and infiltration a common practice in Wisconsin? Just as an aside, personal pet project of mine.
There are opportunities for reuse. We have a small pilot project with our wastewater where we're reusing that to irrigate a golf course. But that's not a huge thing in this very water-rich Midwest that we live in, but it's something we have to consider going forward. We've had those buckets of clean water or dirty water, but there are significant number of uses of water that we're discounting because we've decided that they're not viable. We have treated groundwater or treated surface water that we're using to flush toilets. Could we use something else? Probably. Can we make a cost-only case to make that happen? Probably not. So if we're looking at our really, really cheap water resources and we're trying to figure out how to make reuse a viable option, we've still got some significant work to do.
And for chloride and stormwater infiltration in Scott County, that's probably not happening except down in the Minnesota River Valley, right? Or maybe on 169.
We do have, Sand Creek is listed for chloride, but the documentation completed in the Metro TMDL for chloride shows that that's actually a wastewater discharge issue. We have 3 wastewater discharges to Sand Creek, small communities, and it's water softening. And once water softens, the chloride goes right through the plant.
Lonsdale,
So-
New Prague, and Jordan? Are those
Yep.
the 3? Okay.
Or not Lonsdale, Montgomery.
Montgomery. And they probably do need options for hard water. What are the non-chloride options?
Well, a couple ones. You could soften at the water treatment plant before you distribute it. The Sioux community in Scott County basically does that. And then they have reuse for the golf course, where they're keeping the chloride down. Other one is to have some rebate programs or so forth to get more efficient softeners in. Once it's in the water, not going to really remove it.
Are the Shakopee, Midwakett, and Sioux in Sand Creek watershed, or do they lie outside it?
Mostly outside of it, a small portion of the Minnewaukee and Sioux community does discharge to Sand Creek, but I wear a hat that covers the whole county.
Yeah, because they do model some really great water behaviors there. Let's move on to the next question. What other investments into research did you make or are you making in order to make adaptive management work? You mentioned the leaf phosphorus study. Are there other examples of research investment?
There's a couple of really important research projects that are going on. One was Yahara WINS helped fund the Water Resource Management Practicum, a graduate level class at University of Wisconsin-Madison, to look at transient sediment. So our water bodies are impaired for phosphorus and sediment, but that phosphorus and sediment hasn't come in the last year. It's come in over hundreds of years. And that sediment, sometimes 4 foot deep in the streams, the Water Resource Management Practicum looked at how much sediment there was, where was it, how could they remove it from the stream, and also how much phosphorus was in that sediment. They took the sediment cores and they put water over them, and then they sampled the water. What they found was that water that was over that sediment was actually higher than the water quality standard. So the practices that are put in place right now won't be realized for years and years and years because there's so much phosphorus-laden sediment that's been there for many, many years. So our county took the findings from that study and invested in sediment removal. So they put $2 million into sediment removal projects. They just hired the contractor for their first 2-mile segment, which is happening this fall. And they're actually hydraulically dredging that sediment out, putting it on an upland site and stabilizing it on that upland site and taking that out of the water column. What they found when they looked at that sediment was that the majority of that sediment was more than 25 years old. And that was really important to our agricultural community, because the agricultural community has done a lot. They have been working very hard. We've had a lot of different watershed projects in our region, but by looking at that sediment core and seeing that in their lifetimes, there's very little of that sediment that's come in, but over the history, there's a lot of phosphorus that's sitting in those streams. We also helped fund we have in Wisconsin the SNAP Plus program, which is how agricultural producers look at phosphorus loss from fields. And that program needed some refinement in winter runoff as well as feedlots. So we've been helping fund those projects to update that model such that the results we're getting are realistic of what's actually happening today.
I know you can relate. You have a lot of legacy sediment in your ravines. In Scott County, do you have research dollars, Paul, or do you wish for some?
Most of the research we've done has been with May. We've done the 2 social types of surveys, one in 2011, which was focused on riparian landowners and their attitudes toward buffers and conservation in general, and some of their barriers and motivations and those types of things. And then in last year, we did a second survey of the folks who had participated over the years in our cost share program. So it was a very select group of who actually put in practices and worked with our soil water districts to find out why were they motivated, why did they do it. So this is, your people, they're fairly motivated. And did we provide them good service, which was a very important thing. What could we have done better? How do we improve? It's part of the adaptive management type of thing. And then this winter, we're preparing a third survey, which is a repeat of the 2011 survey to see, based on what we've done to reach out to people since 2011, which has been a lot on the personal relationship side, has that changed attitudes at all to folks? So we're now starting to try to do trends on some of the social things that we've learned.
Interesting. Let's see what else we've got here. Could you explain exactly how the adaptive management system works? How do the practices happen? Who documents changes, and how are they credited?
So the adaptive management project works with a lot of people doing a lot of things. So the Yahara WINS project is providing funding to either practices or to staff. So on the Yahara Pride Farms side, Yahara WINS provides funding to the Farmer-Led Coalition. The Farmer-Led Coalition, it has cost share dollars that they give out to farmers that want to try new practices. And then those farmers try those new practices, and they're documented and verified by Yahara Pride Farms. We do something similar with the Land Conservation Department. Land Conservation Department works with landowners. Landowners sign up for a project. They put that project in. The Land Conservation Department verifies that project, and the landowners get paid. Yahara Pride Farms is working really hard on trying to get new practices to take hold in the watershed. They're doing things like bringing equipment in and letting people try it, letting farmers try it on their field to see if it would work. And if it works, there's cost share money to actually help buy that equipment, but then Yahara Pride is also purchasing some of that equipment that they can just lease out and lend out to different farmers that couldn't afford to actually own the equipment, but want to incorporate that practice into their operation.
And so where does the money come for these groups to go out and verify the practices?
So the Yahara WINS project collects money from about 30 partners based on the percentage of phosphorus they needed to reduce in a phosphorus budget in the watershed. So we have a total number of pounds that we're going after, and we have a total cost that we've determined it will take to get there. And that's based on the practices we know, how much they cost. So Yahara WINS gets that money in, and then we pay the county. We have an agreement with the county that they get paid for staff as well as some practice dollars.
Do you have any similar sources of revenue, or how are you operating your program?
We, as a Scott County, have levy authority.
Yeah.
But the county doesn't enter into this too much. We also are under the Metropolitan Surface Water Management Act, so Scott County, or a large part of it, is the Scott Watershed Management Organization, and that also has levy authority. So from there, we levy a certain amount. We've been very successful at getting grants, and then we also basically expect any partners to participate financially. So farmer signing up for a practice has to contribute 25% or some 50% or some percentage. Also, if we work with lake improvement districts or something like that on aquatic invasive species, they have to contribute so much. And some of that we've developed policies around for the aquatic invasive species. We say, okay, the lake folks benefit the most, so they should contribute some. And it's in our program, but we'll match it because there also is a larger county benefit. We realize people that come and recreate that are not just lakeshore owners. And so we intentionally have expectations of sharing the cost.
Well, I want to be sensitive to your time. I know that you've had a long day. You were at the Met Council all morning and then met with legislators and agency staff leaders in the afternoon. And I don't want to end on a levy note, though. Do you want to wrap up with any kind of motivational one-liner? Either one of you?
I just go back to when I was listening and this idea of going outside the fence and how that means giving up some control and making things a lot more complex. And in doing some of the things that I've done the last couple of years with its social side of things, I've done a little looking at the idea of complexity theory. And I won't make this too complicated, but going back to the idea of building stuff. Complex problems, you can build things to solve them. That's a good example of that is a wastewater treatment plant, where you build one, makes lots of sense to study it very detailed because you're going to invest a lot in that one location inside the fence. And once you build that plant, you have a template for building a second one. And the second one will operate just as efficiently as the first one. But when you go outside that fence and you start working in the watershed, you're working more in complicated situations. And the example there is raising a child. I have 2 kids. Had the first one for a few years, had the second one. I learned some things from the first one, but gosh, that second one was different. And I had to treat it totally different. And studying like crazy, trying to figure out a build model didn't work. So that's watershed management and going
That's
to
a great
complexity.
example. Any final words, Kathy?
I want to empower each of you to do something different, to shake hands with one of your neighbors you haven't met, to look at challenges you have in a different way. As we try to meet new people, we try to break down some of these mindsets that we've had for years, we can do amazing things. So for each of you, I'm really excited to see what you can accomplish and what we can all accomplish as a whole. Thank you very much for coming tonight.
Thank you. Thank you all. I think you're a room of doers, so go out and do.